Hello, Christine Halsey here, and today we're going to look at how to analyze JFET DC values. We're going to look at the calculations and then at Multisim. Okay, so here's our circuit, and from the data sheet, IDSS is 3 milliamps and VGS off is negative 2 volts. And we have these two equations for ID. So we set the two equations equal to each other and plug in the values. Now this equation is over here and this equation is over here, but we set the two equal to each other and solve. Easiest way is plug it in the calculator, or you can use the quadratic equation to solve, and we get the following two answers. Since VGS must be between 0 and negative 2 volts based on VGS off, we'll pick the negative 9.9 volts. So 0.9 divided by the 1K at the drain, and we get 0.9 milliamps. Sorry. Our VD then becomes 12 minus the 4.7K of the drain times the 0.9 milliamps gives us 7.77 volts. The voltage at the source, 1K times the 0.9 milliamps, or 0.9 volts. VG, VGS plus VS, so negative 0.9 volts plus 0.9 volts gives us 0. VDS, VD minus VS, 0.77 minus 0.9, 6.87 volts. Okay, now we'll look at comparing the VD 7.77. We're measuring at 7.608. VG should be 0. And we're measuring microvolts here, so that's their indication of 0. And 9.34 millivolts, 0.9 volts, so 0.9 volts and 0.934 millivolts correspond. Okay, and then if we want to measure GS, negative 0.9, and our DS should be 6.87. .67, so we're right in there with our measurements. Okay, I've also applied for my function generator 1 kilohertz, 250 millivolts peak to peak. Channel 1 to, or channel A to 1 volt, and channel B to 1 volt per division, and you can see channel A is going in. Let's take a marker and measure. This is marker 2, so 250 millivolts approximately, and we're getting out about 1.67 volts. So we're right there where we calculated we should be.